G'day. Today we are modding an Atari 2600 Junior for S-Video and Composite output. It will involve a custom board based on schematics and pretty much setup information from a website called aussiearcade.com and a forum member called Roxbury. Here's the schematics and a diagram of the custom board that we'll be building. There is a bunch of different ways to do this. Here's some of the things you're going to need. A Vero board, which is 20 by 13, some various components, wire, and your output sockets of choice. Depending on what you decide to do, you can use regular S-Video and RCA outputs, or in my case, I'm actually going to build a cable that will go into a custom 6-DIN output, which means we won't have to cut into the case. It'll mean you can use something like this as well, or this. And these are 9-DIN custom cables, which can be purchased, and I highly recommend you do buy them rather than building your own cable. But basically it means that we won't have to cut into the actual console, so it's a no destruction mod. Here's a schematic of what I'm going to do for the 6 mini-DIN output. And this is just an example, so obviously if you buy, but if you choose to use a 9-DIN, it'll be custom, obviously based on your choice. So step one, we need to mark out the size of our Vero board. So they usually don't come in smaller sections, so you'll need to actually mark out the size and then scour your board and snap it to size. So when you're doing this, you want to scour across the holes outside the section you no longer need. That'll just make it easier to snap. So when you do that, you should have something like this. And that can easily be filed down or clipped off with some clippers. Just those rough edges there. So we'll do that again because we need a smaller portion of that. So we've got the 20 holes wide, and now we need the 13 across. And there we go. That'll be the base for our project here. So step 3, begin assembly. So this is the R1 or resistor 1. $4.7K, and we'll solder that in. Onto the rail there. And then R2, the 9.1K. It's a bit finicky. We'll solder that one in. I'm not going to show every single step of this entire project, but we'll just step through the custom board at the very least. Resistor 3, 18K. Now it is a good idea to actually mark out where your components are going to go beforehand. It just makes it easier that when you actually grab them, you know which holes they actually need to go into. This can get confusing, especially on a larger board. This one's a bit easy because it's slightly smaller, only 20 by 13. We've actually had to put that component in at an angle as well because the rails are rather close to each other. So it just sits a bit up there. On to step 7, which is the R5. which is 2K. Spin that in there. Obviously when I skip a soldering step, we are soldering the components down, but it is a bit tedious to see all of those steps. This is another one that needed to go at an angle. One of the pins down. Just speaks to the closeness between those two rails. Step 9, R7, 75 ohm. Another good tip for assembling custom boards like this is lay out your components in order as you'll need them, and try not to take them out of either the packet or the bag they came in. Otherwise you'll have to be pulling out a diagram to look at the colours on your resistors so you don't get them mixed up. Step 11, run to R9, which is the 10 ohm. Starting to take shape, this board. As I mentioned, this came off a forum, and the links to the original post from that forum member are in the description below. R10, 6.8K. I have altered this mod from that forum post slightly. We'll talk about that more shortly, but essentially in other mods that I've done, I have drilled into the case of some of my consoles. I really didn't want to do that with this classic Atari. It's R11 there, which is 75 ohm. And yeah, I really wanted to make this a no destruction mod that could be undone, which is becoming more popular. It just means if you ever wanted to return it to an original state, you can. I think the mini DIN approach is the way to do it, rather than drilling those RCA sockets into the side of the console. The great thing about this mod is it's super straightforward, right? Handful of components, some simple soldering, and you get much clearer, crisper outputs. Alright, so step 15, the first capacitor, C1, which is 100 microfarads. Just goes into the bottom there. Step 16, C2, 10 microfarads. So this one's a bit of a stretch, so I have to use pretty much the entire length of the legs of this capacitor. Just managed to get that happening there. It is quite frustrating soldering this board on the table. I couldn't find my clip stand for this, but we'll make do. Alright, and this is the first of the NPN transistors. The thing to note about this component and the next, definitely put them in the right way. So notice the flat side is facing one side of the board. Like so. Both facing the same way in this case. Solder them on. Step 19 is the diode. Now, you may not want to drill your board here. What actually happened was the part that I ordered was actually a larger component. It's a 75 volt diode. And actually, the store wasn't open at the time, so couldn't go back and get a smaller one. And I didn't want to pause the project for a couple more days, so just really finely drilled a bit wider than the existing hole. I think this is an 0.9 mil board, and it managed to fit in there. Now I will say go with a smaller diode, and don't go drilling your board out. You may mess it up and do some damage. Alrighty, step 20, we are onto some of the wire traces on the board, which connect up some of the components. So just get a bit of wire, snip it to length, or a bit further over length, because you'll need to obviously pair this wire out and then solder the end and clean it up so it's easier to insert. Probably get some dedicated wire pairers, but I just like to use snips. The way to do that is just you lightly press down and turn it, and eventually, whoop, bit of an effort with this one. Sometimes it doesn't come cleanly, and then you just twist your wire, solder it up, and then on it goes. So that's, I won't go through all the traces, so that's all of them done. And that's pretty much the board sorted, not including the inputs and outputs. But onto the console. So step 21, we're opening up the Atari. It's just got the simple screws on the back. It's nice that there are none hidden on this board. You don't have to lift any stickers or anything like that, just around the outside. And as far as opening this case up goes, there's actually these two clips which are hidden either side, just on in those vents. There's actually one in the middle as well, but it's usually okay to either get a screwdriver or, there we go, some tweezers just to press against those clips and it will snap off. Step 22, we need to lift the shielding, and I'll just set some details on the board here. So the serial number, not quite sure. Haven't worked with these boards before. This is the first time, but we'll lift those tabs, and it's just a case of either twisting or bending them just till they're flat, and then you can lift that shielding off. So they're on the underside, and then the top part comes off there. There we go. All right, so let's test fit our custom board here. So if you did successfully clip it to 20 by 13, it should slot in there nicely. And we will be wiring up components to the board around the place. Down in the description below, I've made a custom non-technical diagram of where things need to go. So in terms of running the input wires here, we could actually go around the back, but I mean, sometimes it's good to take the shortest path. In this case, we will actually, I think, drill into the shielding. But first things first, prep some of your wires. So this just means when you're soldering down to the board or trying to insert them into the holes, you don't worry about the individual strands of the wire coming apart. It just makes working with it a lot easier. Alrighty, so this is the sync cable. Okay, and I've skipped ahead here, so we've just wired all of that up. So that's the all of the input minus the color input. We'll get onto that eventually. We've got ground in the brown cable. 5 volt is red. Orange is sync, and I won't go through them all, but refer to that schematic in the description below. So this is the output side. So in this case, blue is LUMO and yellow is CHROMA. And that hole there will be used for an audio wire, which will run on the bottom part of the board. Just trying to organise the wires together here. And I think I've decided, rather than going around the top, just to drill a neat little hole here in the side of the shielding. Just mark that there. As I said, you can sort of wrap it around the top if you really want to not touch that shielding. But we've just drilled that off camera, and make that hole big enough if you do choose to route the wires through here. I think you want at least like a 5.5 mil drill bit. Just trying to find ground here, confirming where it is on the board. Alrighty, step 27. We're going to wire ground from the custom board to the Atari board. Just snip that to length there. And we'll need to prep that wire as well. It's probably better if you measure that to length and then prep it beforehand. I've attached it to our custom board and then prepped it whilst it's attached, but might be better to do it the other way, depending on what you prefer. Finally found my little clip stand, so we'll put that to use. Definitely comes in handy to hold your components and wires and whatnot as you're soldering them. And we'll just attach that to the board. You want to use really sort of short ends when you're attaching it to the board. You did see I left a long strand, but you do snip that down before attaching it. Step 28 is wiring up the 5 volt to the board. Another good tip for these boards is to add solder to the actual pad before you attach it. Attach a wire, it just makes that solder grab a little bit easier initially. Step 30, we're going to do LUM0. It's being a bit finicky here. LUM2, step 32 is LUM1. So again, the resistors that these are going to on the board, you'll find in the non-technical diagram attachment in the description below. Just makes it a fair bit easier to understand where things should go. This is the audio cable, so this will actually go straight out to your output socket. Doesn't actually need to run back to the custom board. This is a step that I forgot earlier. It's actual color in, which needs to go there. So we'll just add that on. I suppose it would have been worse if I'd forgotten it after I'd closed everything back up. It's a bit finicky to do this with all the other wires holding it down, but we'll get that job done. And then attach it to the board. Alrighty, step 35, organize those wires. So it's handy to have zip ties here. So this is feeding in through the audio wire at that side of that shielding, and then we'll zip tie some of those wires together before and after that hole on the shielding. You do want to keep them sort of quite tight where that cartridge slot insert is, because if the wires hang out too much, then you won't get the top of the case closing properly. So it's just a bit of back and forward, opening it up, tightening those zip ties a bit more. And when you're happy with it, snip the ends. And we'll do a test fit here. Putting the shielding back on here, step 36. Tip when you're putting the top base back on the board is make sure your switches are aligned, because I definitely popped mine out. So I'll need to get a replacement. So don't damage yours. So here I'm just finding another general ground location on the board, just confirming it's ground here on these two little pads on the right, because we will use those pad locations there to run to our output socket. So just sort of measure those off. That looks about right. It's always good to go a little bit longer. May have cut this a little too short, but we'll make it do. Okay, so step 38 is desolder the RF output socket. So this takes a little bit of effort. You really need to get that solder tip in there. So lift that solder, and then eventually it becomes loose, and then just give it a jiggle. Don't be too firm with that. You do want it to be quite loose when you start doing that. And step 39 is desolder the three-way switch. Similar process here. It actually takes quite long, so just be careful with it. Make sure you remove all the solder before you lift it. And what we'll be doing with this switch is flipping it upside down and gluing it in place here. Now you might need to use a fair bit more hot glue than I've used here. I just sort of did this initially for a test fit to make sure it fits on the actual, well, it doesn't foul on the outside of the console case, but you will need to cover it with a fair bit of hot glue even over the top of it just to hold it down. Step 41, CHROMA out, LUMO out. So these are the two wires coming out of your custom board, and they'll go to your output socket. So whether you're choosing to do an S-Video 4-pin, or whether you're doing a custom 6-DIN like I am, or even if you choose to go a 9-DIN and use pre-made cables, then this is very similar to the step. So it's essentially just LUMO on one side, CHROMA on the other, and refer to the S-Video spec for that. I'll link that in the description below as well. So in this case, CHROMA is yellow and LUMO is blue. And this is going onto my 16 output socket. It's always good to add a bit of solder to the pin before you attempt to add the actual wire, and cut those wire tips quite short, just so it makes the connection a bit easier. So next steps are the 2 grounds. So this is essentially, if this were a 4-pin, that is the setup for an S-Video socket. So LUMO and CHROMA on top, and then 2 grounds below. But as I said, we're using the 16 here. So this is actually now, I'm using pin number 5 down the bottom to be audio out. And that's the audio that runs to the board through the side of that shielding. And these next steps will take some attention. So what we're doing here is CHROMA from the board to the 470 picofarad capacitor. So this attaches to the same CHROMA pin as it does from your output board, and then this goes to the middle of your 3-way switch. So this is step 44. This is the actual picofarad capacitor, which I've just soldered straight to the middle of that switch. I mean, you can do this a bunch of different ways, but I thought this was the easiest. So that's the other side of the wire that we just did, to that going to that DIN, and what either on the left or the right of this switch, you then, in this case, I'm going to use the left side, and this is actually going to go to your composite out DIN. So I've made this cable wire blue because I sort of ran out of the colors, so it'll get a bit confusing, but essentially this goes to, if you had a composite jack, this goes directly to that jack as the CHROMA portion. It is still CHROMA, even though I've made it blue, which is confusing. And we're just gluing this CHROMA cable down here. What I haven't shown here is this blue cable, which is CHROMA, that goes to your output jack, which is composite. You'll also need to have LUMO going to the same jack from your custom board. Here's my custom cables that I made. So this is essentially 6-pin custom input on one side, and then it connects to S-Video, and then composite, and then left and right audio on the output. And then we're putting it all back together. So step 47 is gluing the board down. Now, obviously, before you do this, test everything, and I've already done that off camera, and we're working fine. So just nice big clumps of hot glue there, so you're not actually touching any of the components below. It doesn't really need to stick that well here. It's just more of a buffer, so you're not touching any of the components as mentioned. Now for me, this next step is actually temporary. I'm gluing the socket down. I don't want to drill it into the actual case, which is this variety of socket. That's because JCar were out of the type where you can screw in the actual DIN socket. So I'll find that variety at some point later down the track, and I'll actually use that screw mechanism to attach that. Alrighty, so reassembling. Snaps in quite well there. Just making sure we don't have any cables sticking out. And then we have it. A no destruction reversible S-Video and Composite mod for the Atari. Click that switch back in there. And here's some examples of it running a couple of games. Here's tennis, Kung Fu Fighter, I think it is. Here's Frogger. And these are all S-Video, I should state. And I thought I'd do a comparison as well. So S-Video on the left here, you can see, if you look at the details on the cars, slightly crisper, which is nice. Alrighty, that's pretty much it. Thanks for watching, guys. I'll catch you next time.